Okay, so in this walkthrough, I will show you how Orca AI works end-to-end. We will spin up the full stack with a single command, take a quick tour of Orca UI, then build a small agent pool with GraphScout and 9 local LLM agents. In the end, you will see Orca execute only the agents that are actually needed to answer a question, instead of blindly firing everything. Now let me give you a quick tour of Orca UI. At the center, you see the main canvas. This is where the cognitive graph lives. On the left, there is the node palette with all the available agents and service nodes you can drag into your graph. When I click on a node, the Properties panel appears, where I can configure prompts, models, and parameters. On the right side, there is the YAML preview, which shows the orchestrator definition that Orca will actually run. Below, you have the Execution panel that will display live logs and results. At the top, there is the toolbar with common actions, and in the corner, you can see the canvas navigation controls to zoom and move around. Finally, at the bottom, there are quick example flows and an upload button to load your own YAML. Let's build something interesting. From the node palette, I drag a GraphScout node onto the canvas. This node will decide which agents to activate. Then I add 9 local LLM nodes and arrange them into 2 clean rows, so you can see them as a pool of possible experts. Each local LLM node represents a local model with a different role or specialty that we will define in a moment. Now I start configuring the logic. I select the GraphScout node, and I connect its output to the local LLM 9 agent for the final synthesis step. In the Properties panel, I define the maximum depth and the weights that control how aggressively GraphScout explores the search space. Then I set the core prompt for GraphScout. I paste something like, find best path for the given topic, get input. This get input tag is an internal input reference that will be replaced at runtime. I also add an instruction to explicitly exclude local LLM9 from the candidate list that GraphScout can pick, so this node is only used at the very end as the synthesizer. When I am done, I save the configuration and move to the local LLM9 agent. With local LLM9 selected, I turn it into a kind of adaptive meta assistant. I set this prompt. Act like an adaptive multi-role assistant and answer to this topic, get input. Before responding, silently consider several complementary approaches, such as analytical reasoning, step-by-step explanation, practical guidance, critical evaluation, reflective questioning, and simple illustrative examples. Then, synthesize the most useful elements of these approaches into one coherent answer. Adjust the depth, structure, and tone to match the topic and the implied needs of the user, keeping the response clear, honest, and as concise as possible. Base your answer on previous output from LLM models. Previous output. So this agent does not think in isolation. It takes the previous outputs from the other local LLMs and uses them as material to build a final, coherent answer. To show model flexibility, I switch its model from DeepSeek R1.5b to Llama 3.23b, keeping everything local but a bit more capable. Next, I configure the rest of the pool. For each of the other 8 local LLM agents, I assign a specific role, always using the same pattern. Act as a role and answer to this topic. Get input. For example, one can be a critical reviewer, one a practical tutor, one a system architect, one a security analyst, one a product strategist, and so on. For each node, I align parameters and capabilities with its role, so the prompts and the configuration match what that persona is supposed to do. At the end, I have a small society of local models, each with a clear job. Once everything is wired and configured, I go to the YAML preview panel and click on Generate YAML. Orca UI converts the visual graph into the orchestrator YAML. I scroll through it quickly to validate that the agents, the fork, and the routing are correctly defined, that GraphScout has the expected weights, and that the connections line up with what we see on the canvas. This YAML is what Orca will actually execute. Now it is time to run a real question. I open the execution modal and define the input for this workflow. I type, you are an LLM model running within the Orca reasoning framework. What benefit are you getting from being executed in this environment? Base your answer on observable available data.
Running and interpreting the result, I press Execute, and Orca runs the workflow. In the execution panel, I follow the logs as GraphScout evaluates the agent pool and decides which nodes to call. When the run completes, I scroll through the trace and highlight the key detail. Out of the 9 local LLM agents that were available, only 3 were actually selected and executed to build the final answer. We can see GraphScout choosing the path, calling just those 3 agents, and then handing their outputs to local_LLM9 for synthesis. The final message explains the benefits of running inside the Orca reasoning framework, grounded only in data from this execution, while the other 6 agents are never invoked. That means fewer model calls, fewer tokens, and lower latency. This is Orca-style orchestration: intelligent routing, minimal execution, and a clear answer with strong cost and processing gains.
Still building LLM chains? Time to upgrade to real cognitive graphs.